Hello students, welcome to AriserTalent. I am your teacher Arpita Sharma. We are studying maths and so what we were studying triangles and we have studied some theorems and have done some exercises. Now again with the theorem that I have left for you was theorem, the internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the sides containing the angle. Okay. So, what it is trying to say is that if I am having this triangle, let us not make here, let us make it here because we have to do some constructions. Okay. So, I am drawing it here. And this triangle I have named A, B and C. Now, it is saying the internal bisector of an angle. Now, let us assume this is talking about this angle A. Okay. So, of a triangle divides the opposite side. This is the opposite side of this angle. It divides the opposite side internally in the ratio of the sides containing the angle. Now, these are the two sides that are containing the angle. So, basically this ratio, this will be equals to, if this is the bisector, if this is the bisector, then this ratio this should be equals to this ratio this. So, let us assume that it is point D. So, we have to prove what? In this figure we have to prove that AB by BD, AB by AC. Okay. AB by AC is what? Ratio of the sides containing the angle, okay, is equals to BD by DC. Now, BD and BC are what? BD and BC are what? Internal bisector of angle and triangle divides the opposite sides. So, it is dividing opposite side. So, we have to prove this. Okay. So, first make this. Okay. Now, what you have to do is extend this. Okay. Now, this is your line AD. Make a parallel line from C which is parallel to AD. Now, it will definitely meet this extension somewhere. Let us mark the intersect of these 2 points, as we are having A, B, C, D, we will be going with E. So, that is E. Now, this is our angle A, this is our angle 2, right. Now, this is our angle 3, this is 4 and this is 5. We will let you know that why we are marking these angles. Okay. So, angle 1 equals to angle 2, you can see here. Now, we are going to prove this thing. Come here on this part, proof. You will do all the things that you are extending AB such that we are such that the line EC is parallel to DA and the extension of AB is meeting at E. Okay. Now, angle A is equals to angle B, angle 1 is equals to angle 2. Why? Because we have bisect this angle. This is a bisector. So, angle 1 equals to angle 2 because it is bisecting. Now, you can see that this line and this line are parallel lines and this line is cutting them. So, this is basically okay. Now, you can see that this angle, or you may say angle 2 is equals to angle 5, okay, that will be angle 2 and angle 5 will be equal. So, by construction you can say if these two lines are parallel and a line is cutting them, then this angle is equals to this angle because of alternate angle, okay. So, you can write angle 2 equals to angle what? 5 by what? Alternative angle. Okay, so we are having 1 equals to 2 and 2 equals to 5. So, basically 1, 2 and 5 are equal. Now, this angle is 5 and this angle is what? 3 and 4. Now, we have to look which angle are again equal in this figure. So, we can write here 1 equals to 2 equals to angle 5. Okay. Now, talking about angle 4. So, angle 4 is here and angle 1 is here. Okay. So, this line is cutting, this line is parallel to this line. So, we can say as AB is parallel to line EC. Okay. If AB is parallel to line AC, we can say that angle 1 is equals to angle 4, right. What does that mean? That angle 1 equals to angle 2 equals to angle 5 is equals to angle 4. Okay. From this you can say that in this triangle angle 3 is not here, but angle 4 is here and angle 5 is here. Angle 4 and 5 are equal. So, if these two angles are equal, these sides will also be equal. So, in triangle EAC, angle 4 equals to angle 5 by equation 1. Okay. So, AE will be equals to what? AC. Now, students, you are having this triangle BCE and in this triangle you are having this AD parallel to EC. Okay. Now, you can apply your basic proportionality Thales theorem in this triangle. Okay. Applying Thales theorem in triangle what? BEC. So, you will see that because this is parallel to this. So, BA or AB we can write here AB by AE will be equals to what? BD and DC. Okay, right, BD by DC. Now, we have seen we are having AB here, okay, and AC, but here it is AE. Now, BD and BC, BD and okay, I have written this wrong here. Okay, correct it. AB divided by AC will be equals to BD by DC. Okay. So, these three terms are same as it is. Now, this term we have to replace. Now, we have this term like A equals to AC, because we have proved that this angle 4 is equals to this angle 5. So, AE equals to AC, we will just replace the value of AE as AC. So, we will write here AB, because AE equals to AC, we will write AC here, BD by DC. Okay, so let me write here for you, so that implies AB by AC, AC in place of AE, and again BD by DC. Okay students, so as you can see, this is our required result. So hence proved. Now student, make this diagram and note this. Okay. So this was about the internal bisector. So we can assume that there must be a question of external bisector also, right? So we will prove that also. Okay students. So moving to our next question, I am having here the external bisector of an angle of a triangle divides the opposite side externally in the ratio of the sides containing the angle. It is saying that if you are having an external angle bisector, this is your triangle ABC, this is your main triangle, and the external angle will be this angle KAC, this will be the complete external angle. Now, if you bisect it, that such that angle A equals to angle 2, if you bisect it, then bisector of external will divide the opposite side, this will divide this opposite side externally in the ratio of the sides containing the angle. Now, sides containing the angles are AB and AC. Okay. So, ratio of this to this should be equals to ratio of this to this. Okay. Right, understanding this. Now, we will start work on this. Now, students, by construction, what we are having, angle 2 equals to angle 1. No, this is not by construction students, actually angle 1 equals to angle 2 by what? Because of it's bisecting, so it's a bisector. So angle 1 is equals to 2. Now what we have done, we have this line AD, okay. So we will draw a line EC such that EC is parallel to line AD, okay. If you are not understanding it properly, let me draw it for you. I was having this triangle A, B, C, okay. Now this was the external angle A, okay. I thought that I will be bisecting it in two parts, and I decide to bisect it and extend this line, okay. Now I extend also this line. So the intersection of these two lines created a point, and thus we have another triangle AC, and let us see it is D, right. So now this is the bisector, and this is the extension, okay. Now what I have done, I have from point C, I have drawn a line parallel to AD, okay, and I named that point E. So this is the same diagram I have mentioned you here. So, do not be confused in the construction part, because this is not the triangle we are talking about. The original triangle is this ABC, as we always take, right. So, by construction we are having this line, look, this line parallel to this line. Now, if this line is parallel to this line, you can say that angle 4 is equals to angle 2. So, by construction, EC parallel to AD implies that angle 4 is equals to angle 2. Okay. Now, look at this angle 3 will be equals to angle 1, alternate angles. Okay. These 4 and 2 were corresponding angles. Corresponding angles, students. And okay, students, so these are our corresponding angles. So, these two angles are equal. Now, come here, we have taken care of angle 1 and angle 4. Now, angle 3. Now, if you look at this diagram carefully, this figure carefully, you will find that this line is the one who is parallel to this line, and this line intersecting the both parallel lines. So, this angle 3 will be equals to what? This angle 1. Okay. So, you can write angle this was what? Angle 3. Angle 3 is equals to angle 1. Why? Because EC parallel to AD. So, they are what? 3 and 1 alternative angles. Right, students? So, ultimately we can say that angle 1 equals to angle 2 is equals to angle 4 is equals to angle 3. So, we can conclude from this 1, 2 and 3 equation number by equation 1, 2 and 3, what you can conclude is angle 1 equals to angle 2 equals to angle 3 equals to angle 4. Now, in triangle what? This EAC, what you are having? Angle 4 equals to angle 3, angle 4 equals to angle 3. So, if angle 4 and 3 are equal, then EA and AC will also be equal, students. So, you can write, this implies that AE will be equals to what? AE will be equals to this line AC. Okay, noted. Now, look at this bigger triangle ABD. In this triangle, we are having EC and ED parallel to each other. Okay. So, this is a triangle and this line is parallel to this line. So, we can easily apply Thales theorem in this triangle. So, in triangle A, B and D by Thales theorem, what we can say that in this triangle BE by EA, BE by EA is equals to BC by CD, BC by CD. Have we written it right? BE by EA will be equals to BC by CD. Okay. Now, this is BC and this is CD. Okay student, now this line is opposite to this angle. So okay, we got these proportions as what we have required. Now we will be getting BE by EA, that is BE by EA. Okay, now can I write EA equals to EC? Yes. Okay, so that can be written as, from here you can put AE equals to EC. So that will be BE by AC equals to BC by CD. Okay students, now you can see that BE by AC, that is BE by AC, that is AC, okay, is equals to BC by CD. Okay, here's a mistake, that should be AB. Okay, so we can apply the corollary of this theorem. So in triangle A, B and D, this BD by this CD will be equals to what? This divided by this will be equals to what? Complete line AB by AE, this line by this. Okay. Okay students, now I can write what? From here I can write A equals to AC. So I will write it BD by CD equals to AB by AC. Now have a look at this. What is BD? BD is this, by CD, CD is this. So the opposite side's proportion is there, BD and CD. Now look at this. This is the external angle, and this angle was bisecting. So this angle A was made by this and this side. So this is AB. What is AB here? AB, and this is AC. This is AC. So we have proved it. Okay students, hence proved. Noted. Now we will do a question on it. Prove that the line joining the midpoints of two sides of a triangle is parallel to the third side. So what is it saying is that the line, prove that the line joining the midpoints of two sides of a triangle. I am saying that if this is a triangle A, B and C, the midpoint of AB is somewhere at D, okay, and the midpoint of the line AC is somewhere at E, and then I meet these 2 points and that line DE. Okay, now it's saying that triangle is parallel to the third side. So midpoint of these 2 lines is this. It's saying that prove that it's parallel than this side. Okay students, so by construction what we are having, AD equals to DB and AE equals to EC. So, AD by BD is equals to what? Let the value of AD is x and value of AE equals to y. Then this value is x. So, this value is x also, this value is y, then this value is y also. So, x by x will be giving you ultimately what? 1. So, AD by DB is 1. This is your first equation. Now, again AE, because it is at midpoint, so it is dividing in same ratio. So, ratio will be 1. So, this is second, okay, and by first and second, by equation first and second, what you can conclude that AD by DB is equals to what? AE by EC, AE by EC. So, have you looked at anywhere else, it is familiar or not? We are always saying that this AD ratio this DB equals to AE ratio this EC will be give you what? This is according to Thales theorem. It is proven that if this applies, then what? Converse of Thales theorem, this is parallel, this DE parallel to BC, because we are getting this relationship. So, applying converse of Thales theorem, DE is parallel to BC, and this is the one thing we have to prove. So, it is proven again. Note this, students, okay. Now, we have talked enough about the triangles, Thales theorem and proportionality. Now, we will talk about similarity, okay students. So, criteria for similarity of triangles, we will be reading criteria of triangles in our next session, next lecture, okay students. Till then, keep watching. Thank you.